Hello student, today we will complete our next topic of chapter complex number. Topic name is geometrical representation of complex number, means how we will able to represent a complex number on graph paper or on a complex plane. Then this we will complete in this topic. So suppose they are given to you one example and they said to you represent 1 plus 2 iota complex number on the complex plane. If we want to represent it on the complex number, means on the complex plane, first of all we have to create a point. Suppose that this complex number will represent a point P, and here the coordinates of the point P, first is the real part and then we will write the imaginary part, means 1, 2. Clear? P 1, 2. So now we will represent it on complex plane. First of all you will create like this. This is your positive x-axis, this is your negative x-axis, this is your positive y-axis, and this one is your negative y-axis. This is origin, value of it is 0, 0. Now this is 1, 2, 3 and this is 4. 1, here is 2, here is 3 and here is 4. Now we will represent point 1 and 2. On the x-axis 1 and on the y-axis 2. This is your P point. P join with the 1 and the same P join with the origin. We have to join it with origin also. So this is our representation of complex number. Clear? We will solve one more question. Suppose now they are giving you such type of example, 5 minus 7 iota represent this complex number on the complex plane. So we will take the point P and the coordinates of the point P is 5 and minus 7. Again we will create a graph. This is my positive x-axis, this is negative x-axis, positive y-axis, and this is negative y-axis. So here is 0, 1, 2, 3, 4 and 5. Now inside we will represent minus 1, minus 2, minus 3, minus 4, minus 5, minus 6 and minus 7. Upper side is 1 and 2. This is sufficient for our point. Our point is 5 and minus 7. On the x-axis it is 5 and on the y-axis it is minus 7. On the x-axis 5. This is our point, and on the y-axis it is minus 7. So this is our point P. So P will join here and the same we will join with the origin. Clear? So this is our complex number 5 minus 7 iota. Clear? This is our 5 minus, this is a straight line. This is our 5 minus 7 iota. Clear? Sometimes they will give you such type of questions. They can give you such type of statement. Write the complex number. Write the complex number that represent the following points in the plane. So first part they are given 2 and 3. Second part they are given minus 1 by 2, minus 1 by 2. So simply we have to write it as a complex number. This is our real part, so we will write 2 plus this is our imaginary part, so we will write 2 plus 3 iota. Same way, minus 1 by 2 plus minus 1 by 2 iota. These are our complex number. Clear? Now this is only the represent of the complex number on the complex plane, and if they are given us the point, and from the point how we are able to create the complex number. These are the two types. Now the next type, they can give you such type of example that perform the indicate operation and find out the result in the form of x plus iota y. So whatever the operation they are given, we have to perform, and afterward we have to represent the number in the form of x plus iota y. So first part they are given minus 3 minus 2 iota plus minus 6 plus 3 iota. We have to first of all perform the operation. Here the operation given addition, and after addition we have to represent this in the form of x plus iota y. So if we want to add two complex numbers, then real part is always added into real part and imaginary part is always added into imaginary part. So minus 3 plus minus 6, clear, plus imaginary part, here imaginary part is minus 2, here imaginary part is 3, here imaginary part, and iota I am going to take common, clear. So minus 3 minus 6, minus 3 minus 6, it will be minus 9. Minus 2 plus 3 is 1, so it is minus 9 plus iota, and it is in the form of x plus iota y. We will solve one more part. Suppose they are giving you such type of example, 1 by 2 plus 7 by 2 iota minus 4 plus 5 by 2 iota. First of all we have to perform the operation, and here they are given operation subtraction. We have to subtract the complex number, and afterward we have to represent in the form of x plus iota y. So real part will be subtracted from the real part, imaginary part will be subtracted from the imaginary part. So 1 by 2 minus 4 plus 7 by 2 minus 5 by 2 iota, clear. Here take LCM, it will be 1 minus 4 2s are 8 by 2 plus 7 minus 5 by 2 iota, it is equal to 1 minus 8, answer will be minus 7 by 2 plus 7 minus 5, 2, 2 by 2 is 1, so minus 7 by 2 plus iota, this is your answer, clear. Here we will solve one different type of example. Sometime they will give you such type of example like prove that z modulus is equal to minus z modulus, clear. Now what is the modulus? Firstly we will find out that what is the meaning of the modulus. Suppose that they are given us a complex number a plus iota b, and we want to find out the modulus of this number, and modulus of the complex number is always equal to square of the real part plus square of the imaginary part, means a plus iota b modulus is equal to under root a square plus b square. Here we have to prove that z mod is equal to minus z, so we will take let z, the general form of our complex number, z is equal to x plus iota y, clear. Minus z is what? We will multiply minus with all, minus x minus iota y. Now we will find out z mod. Z mod we already know that how we are able to find out, square of real part plus square of imaginary part. Now we will find out mod of minus z. It will be minus x square plus minus y square, square of real part plus square of imaginary part. Now minus square is always positive, it will be x square plus y square, and it is same as the value of z modulus. So from first and second, from first and second, z modulus is equal to minus z modulus, hence proved. Now you are able to solve the related question from your book exercise. Complete the question. Thank you.